So I record it so in case you miss the class or whatever reason, you can do it again. So let's get started. I think we can go to this. The course outline. I think the back here hear me, and in the Zoom people hear me. If the Zoom people didn't hear me, they'll say, please send me a message or email. Let me check if I have in the Zoom. No. Because someone is not in the Zoom yet. Let's see. Okay, I think has. I think have turned the room, I guess. Oh, okay. I don't know. Sorry to make sure that. Want to make sure. Is it on the right one? Let me check. Yeah, I think it's right. Let me copy the meeting ID and then. Okay, so. Sorry for the first class, a little bit issue here, but I hope you can bear with me. But let's get started. This is statistical class. I think it's required for everyone who do business, and either me or other people. So I guess there's not too much choice. I think our TA is not here yet, but I think he will soon arrive because he's in other sections. So this course, I mean, you don't have choice, but what we cover is the basic statistics, and we'll cover the fundamental thing. And if you study the M1 math in Hong Kong, the system, actually it covers almost 75% of that. Okay. Then basically we cover the descriptive statistics, probability and inference, and hypothesis testing. That is covered in the high school math. So what is not there would be the ANOVA and regression. But ANOVA basically just a comparing group means more than multiple groups. And regression we do is simple linear version, so it's just extending ANOVA to from categorical variable to continuous one. So by the subject matter itself is not very complicated. So that's why this class focuses on application. Okay, so this is a standard thing, same for all of these other sections. So if you are shopping around, doesn't really matter, so you'll be same. Okay, so the same topic, just different lecture would have different focus. So you should receive the same syllabus, and in our class we would focus on Excel because this is still the most often used software. And probably you might have noticed, I think 1 or 2 days ago, maybe a few days ago, actually Microsoft announced that Excel will be supported by Python. So from very soon, probably not this year, it's not public yet, but very soon, I mean, Python will be directly included in the Excel. I don't know we have time to cover it in our course. We try, but if there's some time, then we'll book a lab to do some more programming class. But in case we don't have time, which probably the case is, we have did I write it down here? Yes. I have applying for datacamp.com, which is we have a free account that allow you to access all premium content 3 months even after this course. So you can go there, you can learn by yourself, and then go to R or Python. Excel we cover in this class. R, I can share the slide with you because I prepared previous years, depend on time. And Python and R will be very similar anyway. So you learn one way, the other would work out. So it's not, but Excel is very different. And it's a good luck that we don't have that. Is where we some of, let me write that down because I think one of the student unable to I don't know how to do that. What I can do is try to, sorry that a little bit because one of unable to enter. Okay, sorry for that. That would be if you have time, we'll cover Python and I'll but otherwise we'll focus on Excel. Okay. And so the about the assessment, I think will be very standard. We'll be doing the individual open book test at the end of the semester. The exact dates will be announced at the end because likely will be I think will be Friday afternoon sometime. We'll send an email later to see what exactly the time. From experience, actually, we don't need 2 or 3 hours. Probably 1.5 or even 1 hour will be sufficient for the purpose. Because to test the knowledge you have is we don't need very long time. And we have participation will be a standard one, so it's not something how you attend a class and how you participate that one. But I think for the first few weeks, probably we just until the class stable, we are not going to record that one. Of course, I remember you if you participate, but otherwise, it shouldn't be an issue. And for this year homework, I'm trying to think I should be more lenient on that. So as long as you complete your homework in a serious manner, you should get 80% of the credit. If you make some mistake, then we take it out. But otherwise, as long as you make a serious attempt, not copying from elsewhere, do your own job, then it should be fine. Okay. And lastly, is the project. The project will be the most useful thing because try to make sure that you actually work out things. Okay. So some people like to work together. Some people like to work individually. So I don't put restriction on the group size. To be fair, the workload of a 2-person group should be double the 1 person. So what mean page limit? I think I have page limit like 2 pages for 1 person. So if you have 1-person group, you give me 2-page report. If you have 2-person group, at most you give me 4. You don't have to give me 2, but I expect 4-page content, not actually 4-page, but I mean, right? So you see what I'm saying, right? So if that means I'm not entertaining any complaint for free writing. So if you think your colleague is free writing, then just drop him and just submit your own one. So you don't have to stick. I don't collect your name for the group. So just send me at the end. the group send me the whole thing, and then that's it. Okay, so if you think that guy is not working, you just dump him, just submit your own thing. Okay, I don't mean if you think that in the middle of the doing the work is not going to work out, then you can split, it's fine. Okay, so you have to work. I mean, you can work by yourself if you're lone wolf, or you have a party animal. You can just work out together. That's perfectly fine. Okay, and you just try to apply what you learn. Okay, I probably later would put up some example of can you hear me? Yeah, some example of last year's decent work. Okay, not necessarily all the A, but some A minus and B plus. I mean, you will see what kind of work you're expecting. So mainly many of you maybe just take this class and that's over, not taking anymore. So I try to more focus on more apply. Okay, of course to give grade, then we have to give grade. I mean, there's nothing can be substitute, but other than that, I hope you to learn something out of it, especially some programming technique would be very useful these days, right? If without programming, that would be an issue. But we just should try to cover Excel in the class, okay? And in the very worst case scenario, make sure your friend can have laptop during the class. So I probably announce in advance we'll cover Excel, but at the minimum, if you forget to bring the laptop, so you watch the video again, then you can see how to work it out things by yourself. Is that okay? So the textbook, I don't want to deviate from other section, although I don't think that is the best textbook available, but we just keep the standard one using the same other section. And probably you ask, is it required? I don't know, if you have a lot of money, then maybe you want to buy one. And always good to have some copy, or now you have an e-book, so you can get an e-book, much more inexpensive. Or if you don't use it, is it okay to get an A? Yeah, it's fine. I mean, we have lecture notes, that's sufficient. And because it's basic thing, so any textbook will work. And I also have a lecture notes, probably released soon. I mean, that would be there. I also cover everything there. So after lecture note, that should be fine. There shouldn't be an issue there. There are more advanced things, so you can probably want to look at those reference book if you want to do more serious work. But other than that, I don't see if you're not going to continue, then probably not. Probably don't need it. Okay. And so this is tentative schedule. The only changes to this, as I mentioned, I certainly have the call to have present in a workshop on this Thursday and Friday, so probably I skip that one. I email you, and the TA will also come here to make sure that you don't wait for me. only for that. Yeah, that's pretty much. One thing very important is the dishonesty and things that probably is to be emphasized, because probably the first class for you today is I think now is AI is there. You may attempt to use it to generate whatever thing for your assignment. But I can't check whether you use AI or not, right? And sometimes you can't tell. The thing is, one thing is now the AI at this stage is still make a lot of mistakes. So, I mean, ultimately, you're responsible for what you submit, right? So if you make a mistake, the AI, then you cannot claim. So the AI generate the thing, you make a mistake, right? So if you submit it, it's your mistake, it's your mistake. Okay. I mean, probably not important for this particular class, but if other class say, right, if they submit, then they have a wrong reference and figure out that you use a makeup references from the AI, then probably you have trouble. Right. So make sure that, I mean, probably not important for this one, right? But if you try to cite something, make sure that you check your citation properly, right? Some of the citation is actually fake. Okay. I mean, especially ChatGPT, very likely you get a fake version, and you would want to check. I mean, if you really want to use AI, probably the Google one, the citation is more real, or maybe you have to use the 4.0 version, which I mean, AI is very useful too. I mean, probably you want to put your project to ask him to change your English, that is perfectly fine, I guess, right? But you ask him to generate from nothing, probably it's not very good. You have something, ask him to generate, then probably it's going to be fine. If you have zero to ask him to write things for you, then probably disaster will happen. At least right now. I mean, I don't know next year, but at least from my experience, I mean, be careful. So, is there any question before we start? It's a time to ask question for the syllabus and thing, because I have to try to see I don't know how to invite. I don't know. Is there any question? So some of my classmates cannot enter. I don't know. I don't know what to do. Is there any way anyone knows how to do that? No. Yeah, because yeah, to ask the student to watch the record of worship, because you can't really get in. I don't know how to do it. Sorry. First time. So any question about the course? Anything you want to raise, or you want to have some ease of the syllabus and thing? If no, then we just start right away. Any question? No? Okay. Then we go into this one. Or maybe I have to talk a very little bit about our syllabus, right? I forgot to mention this. Okay. So probably you would want to know what we're covering for the whole course. So basically, the course can be divided in two parts. Actually, you'll see our slides soon. So usually we call the topic 1 to topic 4 part of the descriptive statistics. If you go to stat department, they will cover this in one semester. So basically, is the way how you learn how to use probability, learn the distribution and all the math problem, without talking about how to match the data and thing. Okay, so basically, just like we learn the mathematical foundation for statistical probability. Okay, this is the first 4, and the subsequent second half will be talking about sampling, right? So, the first 4 is assuming that we have some ideal case, that is how the probability, how the uncertain event arise, and the remaining one will be saying, okay, let's go back. Okay, the first half is assume there's some property. This is something we might observe, right? Just like you toss a coin, right? The coin will come out. Is the fair coin is equally likely, right? And the question would be, how are we sure the coin is fair? I give you a coin, try to see, tell me whether it's fair or not. All right. So that is a subsequent part. And there's looking at data, that how you're going to data to study what you want to study, right? Suppose I want to know how much income does people make, and because business application, right? Because I need to know how much they earn, and I don't sell my product, right? In that case, if I have the data for everyone, then you're done, right? But very often you don't. We just do a subset of the thing, right? There's market research. And you try to infer the big picture from the small sample you have that requires some assumption or some technique to make sure that you make a good educated guess. That is what is doing from the second half of the class. Okay, so basically, you can imagine we try to give you the idea is how to use data to answer the question we want to answer in the second half. The first half is give you the foundation, how you can make, right? Because as I said, you are using a small sample to infer big picture. How can you make sure your educated guess is actually a right one? Is rely on what we learned the first half, give you the foundation, what we're actually doing is the right thing. Okay, so that is the thing. So reiterate, the first half will be learning the math foundation that will apply to tell us why we can use small sample to infer big picture. And when we try to use small sample to infer big picture, we have to not just telling you what is the result, but we tell you how accurate the result is. That actually rely on the thing we learned in the first half of the class. Okay, so if you learn in the stat department, you will be divided into 2 courses. Okay, but we combine it in one section. Okay, when I studied in CHK 20 years ago in B school like you sitting here, I learned it in 2 semester class for this, but now they combine and condense into one. So that means that we will be skipping a lot of technical details. Okay, and same for this class, we will skip some technical details in order to achieve a much more coverage. Okay, and of course, if you are confused and you want to know more, then let me know. I can refer you to reference, but all the books are there because it varies the basic thing. So I'm not worried about you would be confused or what, because there's always thing there. Okay, but in any case, ask me or ask the TA, should be fine. Okay, I hope I give you some idea what's going on, and then we can start our class formally. Okay, so the structure of this class will be we have everything in the theory at the beginning, and then we have Excel at the end. As I said, if at the end of this course we still have time, we will try to book the lab and do the Python or R. Okay, and but anyway, if you don't have time, it doesn't really matter, because we have the data cam thing. You can just go there and just learn. Okay, and so as I said, the first class is the Descriptive Statistics. Okay, so as I said, there will be 2 parts we cover, right? The first 4 chapters will be Descriptive Statistics, right? Basically, is the data is given there. You try to find ways to represent it, right? And you look at the textbook. Often the first 2 chapters, which we never cover, is trying to tell you, given data, you try to draw better pictures to represent it, table or figures. We are not spending time on those. It doesn't mean that it's not important. Indeed, they are most important part in the business. It's not about your data, it's model impression, right? But the problem is it's hard to teach those, and it's not art. You just learning by doing. Okay, you try to look at how people present their data in a table form, then you learn how to create those. Cannot be taught the rule there. I mean, just like it's like drawing class, right? I mean, you learn some basics, and how to make it nice is your job. Okay, so I think you learn it from your high school, how to present things, right? So I assume you're able to do those, like bar chart, pie chart, histogram, pictogram. You learn in the thing. I mean, it's not something we will talk about that. But what we've covered today, we'll talk about the numerical representation, talk about mean, variance, kurtosis, skewness, these correlation coefficient, all these numbers. I mean, nevertheless, I'm pretty sure that many of you know most of them, but just make sure everyone in the same place and first class, right? So make it easier. Okay. And the second part, we will do inference statistics, okay? So for our purpose, basically we're working on trying to make inference on, say, mean and variance and other things, but mainly the mean for our class, right? We're trying to, as I said, estimate economic growth, elasticity of demand, income based on data, okay, based on survey, so those kind of stuff, okay? And if you want to learn more, that would be a huge thing. So we can only just scratch the surface, really the surface of the surface. So if you want more, you should do the subsequent class, right? 212, 2021, and there are many, many more. Okay. I cannot do justice of this view. There's too many things to be covered. So the next thing is I want to talk about the data. So if I do that, I can't see the time. So remind me, it's 3:15, then we have a break. Okay. I try to make sure I remind myself. So the data, so probably you will see the different type of data, and you would often think it's a trivial classification. Why we care about this? The reason is being, first, if you do graphical representation, there are different type of graph actually would require different type of data, right? If you have a histogram, which means that you have a continuous data, right? And you do a pie chart and bar chart, right? Actually, there's a depends on the data type, will tell you which kind of data you would, which kind of chart you would need. And for different kind of data, you would have different meaning for the mean, median, those kind of stuff. So you have to be very careful about your data. Okay, first is the gender and race, which is a nominal, but sometimes it happens. People, when you do the data, with the gender is 0, and male is 0, female is 1, right? And they calculate the mean of the mean of the gender is 0.05 or 0.662, and they're meaningless. When they're nominal, you put number, that's fine, but that's meaningless, right? You put race, maybe white people is 1, yellow people is 3, whatever people is 4, 4, 5, 6, and calculate mean. Those things are meaningless. Say for the nominal, you put number there is fine, but when you do that, then will be meaningless, right? But gender and race, maybe you would not fall into trap, but maybe the data comes in the number, right? The class is 2021, and the other class is 2022, and so on and so forth. You calculate average of that, then you give your garbage. Okay, make sure that you don't fall on trap on those. Especially, now we have a single data, may be easy, but when you huge data set, right? There's an entry in the column, then you don't know, we just summarize this to your boss, and your boss will just, okay, what are you doing? Okay, it happens. It's not something not happen. It happened in very professional setting. You try to do a average or median from a nominal data. For the mode, it's okay. We'll define those later, but that is the thing. For the ordinal data, it is again calculate ranking, right? The Likert scale, right? You do cost evaluation at the end of this class. You give you 1 to 6, right? And this number is ordinal, just order meaningful. Calculate mean and median is actually not very useful, right? We often actually we see that, right? And you go to tonight, you want to spend time with your friend. You try to choose a restaurant, right? We're going to do look at the rating, right? It's 1 to 5, and then the rating, the mean one restaurant is 4.5, one restaurant is 4.3. Which one want to go, right? Maybe you think 4.5 is better, right? But do remember that the mean probably not very useful, because there's actually no 4.5 star and 4.3 star, right? Actually, calculate the mean in this case is not very meaningful. Maybe median would be a better one, right? Or you have to look at the variance, so on and so forth, right? Maybe 4.3, 4.5 rating the restaurant only have 10 people rate, and 4.3 have more than 100, right? In that case, you would be, we have to be careful. Looking at mean in those cases, have to be very careful. So when doing categorical data, looking at mean and median and mode and so on and so forth, have to be very careful because they're not real number. We try to force a number there. It's not very clear what it means, right? Because how is not comparable, agrees and strongly agree, different person have different meaning, right? So it's not very entirely clear how it add up the things. Okay. And for numerical data, okay, and we have two distinctions, we call discrete and continuous. These two are purely technical, okay? Of course, there are some, when you go to advanced class, that would be a big thing there. Because discrete would require different way to handle the math. If you, from the high school, if you don't learn any calculus, the discrete will be something that you learn from your primary school, that everything would goes, right? But when continuous actually require some calculus, okay? And our class don't require any calculus, okay? So we'll keep some symbol there, but probably everything you learn from discrete will extend to continuous, okay? We try not to involve too much math, but you need to know from discrete to continuous require a lot of math. And you would ask, right, why we need continuous, okay? The reason is being that sometimes continuous is easier than discrete, okay? Sometimes it's discrete, so we try to choose different tools that was easier for our purpose, okay? And probably you know the bell-shaped thing, right? The bell-shaped thing is a continuous thing, so it makes life easy, okay? And for some cases, discrete will be more reasonable. So you have to know what kind of data we generate, okay? And as I said, for your purpose, probably not going to be matter. But when you study further, more advanced class, then it will be meaningful. The meaningful difference between the two. Okay. So let me mention this slide before we go to break. Okay. As I said, we don't cover the visual representation of the data. And I do want to remind you that actually this is the very important thing, okay? And you have to make sure that your report or your project have to contain a reasonable element of visual component. I mean, of course, if I'm teaching the engineering school or teach a stat department, probably we don't care that much, right? But we're in B school, okay? Your boss don't have time, okay? They only can spend 10 seconds. If you don't have his attention, then you're gone, okay? So how do you have attention? Table or graph? Graph is the better, right? I mean, human, I mean, there's no choice. I mean, color attract our attention a lot. So how to use color correctly, how to use the graph correctly will be determine your success. If you want to convey your boss by the data, I mean, of course, you have to get attention from it using this nice chart and then convince with a nice table. And if you're interested, then he will read your analysis carefully. Otherwise, you lose attention, you lose everything. So hopefully, although we don't go over this one by one in detail, I can't emphasize how important they are. Even in my own research, I would convince people using the graph first, right? If the data tells you the story, I mean, you convinced him 90%, right? You just support it with the math foundation, right? If the data doesn't show up, if your result rely on some complicated analysis to show it, probably people would not that convinced, right? Unless you are well established, right? You say, okay, give me this data doesn't seem to be right, but trust me, I put in a black box, produce something that is something to be trusted, okay? If they trust you, that's fine. If they don't, then probably you don't win their support, okay? So hopefully your data will tell the main story. The statistic is just trying to support your finding. Okay, so let's a break of 15 minutes, and then we come back and continue our journey. In the meantime, I'm go over and see if you have any question. So let's resume at 3:43. Yeah, feel free to use the washroom or whatever. I just come over and see if you have any question. So you can ignore me if you don't have any. Yeah, the link will be uploaded. So far, yeah, we did, yeah. You can check our last year as well. Yes. Look, the chemistry is really the just want to look this out. I really put Excel for us, and every time I don't know my time. Yeah, because that is an art. Yeah, it was about this. If I follow that business world, still rely on my friend. And like I said, I have always said like this. Now I soon public Excel. If everyone from one group, I can't do it. So have to have something out of the problem. First year, first bench of the organization. I'm only every day. They become actually all of them become actually yeah, five or something. Both of them B.B.A. from this own production. That's why the business is not very we if I describe it going the right direction or wrong direction, want to learn how to yeah, not much about this thing. How like you do all that. Hi. Okay. I guess the goal today is trying to give you these free representations. Okay. I'm pretty sure that you would learn some of it, right? And then I guess the probably last one probably you haven't learned before. The first one is central tendency. What does that mean? Is basically just like if you're a large data set, you try to give a number to summarize what the data is. What you're going to give is either mean, median, or mode, which we'll define very soon. Okay. And the second one is dispersion, which essentially is saying how accurate your central tendency is. If you give me a mean, how representative your mean, median, or mode is depends on how large variation within the data, how they're spread out. Okay. If you give them a mean of some number, the variance is very large, then I put very little confidence on how representative of the mean is. The variance is very small, then I would trust the mean will be very useful. Okay. So these two are very basic thing. All right. Say you look at the market research, right? Then you look at, as I mentioned beginning, right? Look at how much money people make, right? But you look at how variance they are, right? If you have one Bill.Gates and a bunch of people like me, they're probably not going to sell anything, right? Then, but that would really depends on how dispersed the data you have. And the last two, which is called the shape, okay, is trying to further look at the data. Okay, the skewness. I hope we have time today. We should, or not. If not, I cover the next week. we'll be looking at how symmetric about the data. Is it a lot above the mean or a lot below the mean? Okay. In some sense, it's more like the comparing the location of mean and median, right? Median is in the middle, right? If mean is below the median or above the median would be different, right? Just like imagine the case whether you have a lot of poor people or actually it's a lot of rich people, right? That would be important. And that will affect how you look at the data, right? Because it's actually telling you a further information about the dispersion, right? And the last one is what we call kurtosis. Kurtosis is asking how big are the outlier, right? The mean is looking at the middle thing, median, right? But look at where we end two extremes. Are they big or small? Probably you would be asking why we care about kurtosis, right? We don't have time to cover it, but when we talk about the data, we use the bell curve, bell-shaped stuff. When data have a fat tail where and with extreme values, then the bell curve not really applying. You need to use other technique. Okay, so that would actually give you the idea if the data is not too skewed, it's rather symmetric, it's not have a thick tail, then what you learn from this class, that the bell shape will be fine. If that doesn't follow, then probably you have to be much more careful. In those things, of course, that will require, I don't think the 2021 will cover it properly. You have to get a much deeper classes to cover those. Okay, but that's a thing you need to look at and see if the usual tools you use are going to be okay. Okay, it's a warning signal whether your data have some problem, right? And sometimes you need to care about those. Okay, and don't worry if you try to use a modern software, these things generate automatically. Okay, so it's not something that you have to think about how you worry about this. Is come out, you just know how to interpret those. Okay, is that okay? What we are covering for this class? Okay. Mean, median, mode. I try to be fast because they're not too much. The formula is very simple. Okay, I want to focus you on the want you pay attention on the interpretation, and there's some minor details in the formulas. Okay, the idea is very simple. Okay, let's start with some notation. I'm sorry with notation, but things cannot be said accurately without a good notation. Okay, we have number observation is denoted by n, and each observation is x1, x2 up to xn, so there are n observations. And to be consistent with the textbook and other advanced texts, we would introduce what we call the summation notation. Is the sigma is s, is a Greek letter, capital Greek letter, is adding from 1 up to n. This means that is the notation. You look at the textbook, they will there. Okay, I try not to use it in my slide, but if I happen to use, I have to use it because it saves space. Okay. Another two function which you would also use it as an Excel available there is called the floor function or ceiling function. Okay, and the floor function is very simple. You just take whatever the integer and that's it. Forget about decimal places. Okay, and the ceiling function is as long as there's not 0 in the decimal places, you add 1 to the integer. That's it. Okay, and probably you ask why we do that, why we have this weird stuff. You will use it when you program, when you do the median, interquartile range, those kind of stuff. If you really start from scratch, you need this function to represent. Okay, it's not very important for statistics, but it's important for when you do programming. And I try to make my slide to be consistent with this so that you can, if you try to work on the programming by yourself, you can see, you can use it directly. Is that okay? That will make your program easier to read. Rather than if this happened, you would do that. This is much more convenient way, a shortcut. Okay. And the next thing we want to talk about is the data. Okay, the data is sorted if we the data is from smallest to largest. Okay, it's reordering. Okay, and the frequency is the number of observations that have the same value. Okay, so if the data is 1, 2, 2, 3, f frequency of 1 is 1, frequency of 3 is 1, frequency of 2 is 2. Okay, standard thing when you do statistic when you're in the high school. Okay, and we have what we call relative frequency is over the number of observation. Okay, and we have a frequency table. It's trying to count. When you count, this is the way you count, right? This is a table that summarized from this data, right? And the last one we want to mention, we call the contingency table. Okay, here with data, which is have two categories. Okay, each student can be characterized by his or her gender, male or female, whether he passed or failed the exam. Okay, so that would be the table. We'll use it when we talk about ANOVA, which at almost at the end of this course, but we introduce here first. Now we start our 3 measures of central tendency. The first one is called the mean, or sometimes referred to as arithmetic average. Okay, and that is very simple. It's just adding all observation divided by n. So first, it's very simple, but make sure that you understand what the meaning of this. When you try to say adding something, the add should be meaningful. Okay, for numerical data, that is meaningful. When you, as I said, when you try to add, say, likelihood scale, those kind of stuff, or gender, that will be not very meaningful. Okay, so probably you want to know some property of the mean, right? So we mean is one of the way to measure the central tendency, right? So what is the center? Is the center. So if you try to rewrite the equation, okay, from here, try to write the equation, and actually it means that the mean is at the center of the data in terms of distance. So what does that mean? Look at this one. Okay, we have data x1, x2, x3, x4. Okay, so what is the x bar means? X bar means look at the distance to the left from all data, which represented by the red color. The distance to the right of the mean, which represents blue color. Mean is such that you try to move the location of the mean such that the distance to the left and the right exactly cancel out. Okay, that is center means. Is that clear? So if you learn physics, right, that's basically just like, right, is where the center of the mass, right, where you try to put it there, that's it's not going to turn, right? The moment is 0, they cancel out, right? But anyway, that is the meaning of the mean. Okay, and by what it means, the second bullet point would be saying if you replace every observation by the mean, they're the same. Just to remind you a little bit, when I have this purple color thing, it's the important thing that you should know. When I have the black color thing, means you're welcome to know it. It's not super important, technical, but it's good to know what's going on there. You don't have to worry too much about this thing, but you have to know how to apply this thing. Is there any question? So very intuitive. Okay, so that's the mean. So the green one, usually I have example. Okay, so I would expect you to know the purple thing. Whenever possible, I try to give example, which is a green. So make sure at least you know what does the green mean. Okay, that would be appear in your assignment or in your exams. Oh, I saw our TA here. So at the back, you can say hi to him. So he will handle all the gradings for this class, probably except the projects. Maybe he'll also involved in the project anyway. But anyway, let's see whether he's willing to help on that one. But I'll also handle things. But if you have any question, you can try to email him first. I probably did I mention that? Yeah. So you can email him. I guess because many of you have a different schedule, so we don't set office hour. So, but that means that you should try to, when you really want to seek help from face to face, you should email us with your time slot. I mean, at least 1 or 2, so that we can try to see if we can accommodate that. Okay, because many of you have a different schedule. So if we fix some hours, then not going to help. Okay. Of course, now the technology is so convenient, I guess sometimes easier to do Zoom, just do the Zoom, right? But anyway, in case you really want a face-to-face, so make an early appointment with us, and we try to handle it. Okay. But I guess email would be the most convenient. Of course, the most easiest thing is to ask right away. If your question, just ask, and we'll try to answer it. Okay. So the mean is rather simple, right? Just like adding all the data to the 5, right? Because 5 data is 3, right? And the next one is adding all the data to the 5, again is 12. So one thing you can see from this example is if you accidentally put a 0 at the last one, which may happen, your mean will increase substantially. Okay, so that means what? Your mean measure is very sensitive to outlier, right? When you have large data set, not a problem. When a small data set, that can be an issue. Okay, so that's why mean is good, it's simple, but there's some issue. That's why we need to talk about dispersion, variance after these 3. Okay, we have to look at how accurate they are, right? Because later you will see the variance measure of this one is much bigger than this one. Later you will see. Okay, but that's the thing. And in terms of outlier, okay, there are different ways to handle it. Okay, as I said, it's technical. So if you happen to want to learn it, learn it. If you want to take a rest, it's okay. Okay. So how to handle outlier? There are usually 2 ways to handle it. One we call trimming, just cut it. Okay. See, when you have 50, just cut it. Why? Because this 50 can be coming from some error. So just cut it, then you're done. Okay. And otherwise, it's called renderizing. It means that you replace the extreme value by the closest value you have. Okay. So these 2 are actually operationalizable in most of the software, except Excel. So if you do R and Python, you can easily do it. Okay. You can easily do it. But Excel, I don't think they would able to do it automatically. Of course, you can do it by hand, or there's some B.B.A. or do it. But as I said, I mean, very soon the Python will be in Excel, so it should not be an issue. Okay. So this thing can do automatically. So you don't have to do it by hand. Okay. And the other one, the average, it's called a weighted average, which actually you see very often, right? The most often is called GPA, right? Why you want to study this class more? Why? Because our class is 4 credit, right? The other class is only 3 or 2 or 1. So you have to pay more attention to this class, not because statistics is important, right? Or you like statistics, you like math, but just because it carry higher point, right? And often happen when you have a Hansen index, the same, right? The weight for a bigger stock carry more weight, right? And because different observation is not equal, so that's why you weight accordingly. Okay. And also look at the moving average price, right? If you're a technical analysis, you're a chartist, you would think the closer mean is more important. right? Of course, many of you are accountant, right? And then using my limited knowledge of accounting, right? When you calculate the cost of capital, calculate depreciation, all those things you have to calculate whether by time, whether by the duration, those kind of stuff, right? And depend on different type of assets or different kind of stuff, right? So I'm not going to continue because I'm not good at accounting. So just stop here. So here is the result that you use weighted average, right? So if you do average adding all up, it's just 3. But if you have weighted average, that will be much higher because, so much lower because the smallest observation actually carry much higher weights. Okay. I'm not going to detail for each calculation because it's in the technical part. If you interested, you can ask, you can look at it. If it's the question, ask me. Okay. I'm not going to go into detail for those because it's so simple. I think it's okay to skip. Is that okay? Unless someone want me to go over one by one, I'm just kidding. Is that okay? And another technical thing is actually the simple arithmetic mean is a weighted mean, but same way for everyone, or the weights by the frequency, right? It's actually, when you look at it, it's actually the frequency is actually the weighting for each observation. Okay. But as I said, this is rather technical. I just skip. Okay. And the next two is try to give you some idea that other mean that actually would be useful, but we don't cover. The first one is geometric mean. And if you do finance, geometric mean is more useful, right? Because you consider multi-year return, right? If you have reinvestment opportunity, it's not the average return matter. It's the geometric return matter, right? Because you reinvest, right? So it's a geometric averages matters, okay? And when you calculate the PE ratio investment, it's the harmonic mean itself. Suppose you invest this stock and this stock, then actually the harmonic means matter. But anyway, I'm not going to talk about those, okay? Just keep in your mind that you have different means, and different means actually require different technique. But as an introductory class, we just focus on the simplest mean. Okay. And this is the reason why you would want to care about geometric average. Just a simple example. So consider the return for option 1. First year you got 10%, second year 90%, and second, and option 2 is 50% both year, right? The average net return, same for both cases, is 50%, right? But you look at geometric one, okay? Then you be the second one is better, right? Because with 50%, in both cases, it grows faster, right? Because the first year, what you earn can reinvest, right? So it happens to be important, right? So in that case, geometric is more important. Okay. I should put it technical, so I should grade this guy, but you know what? Is that okay? Now we have the mean, and the next thing we want to talk about the median. Okay. And later we see example. Median is not affected by outlier, and that is exactly the reason why look at the income is the median income, not average income. And to calculate median, one of the good thing is you don't need to exactly know all the data, right? Because you just need to know where is the middle guy and get his data, then you're done, right? I don't need to know how much Bill Gates would earn in order to calculate the median, right? Because he earned way much more than anyone, then just ignore it, just it's fine, right? So the data requirement for median is much less, okay? Because not affected by outlier. And how can you represent the median? Okay, of course, the simplest thing we know is median is intuition is middle data, right? But how can operationalize this middle data, right? If you have 3 observations, the middle is exactly the second one. That's no problem, right? Second, it just come from 3 plus 1 over 2, right? So it's n plus 1 over 2. That's no problem for this one, right? The odd number of observation, they're exactly the middle, okay? But when you have even number, what's the middle? Suppose you have 4 observations. What's the middle? Or even more extreme, you have 2 observations. Where's the middle? Okay, there's no way to tell what's middle. So usually what we do, we just take the average of the middle two, right? So that is exactly halfway of the middle, right? Because when n is even, right? 4 is middle is 2 and 3, right? 4 is half is 2, 2 plus 3, right? 2 and 3. Is that clear why we have this formula? If you confuse this formula, just think about n is 3 or n is 4, then this formula makes sense. That's how you try to read formula. If you don't understand what's going on, take some n example and do it. That make your life easier. And we'll see examples, okay? And probably the most difficult part is how can you operationalize this, right, in your programming, okay? You see 2 different equations. How can you make it the same formula? It's by using the floor function and the ceiling function, okay? Look at this. When n, you look at n plus 1 over 2, use the floor and the ceiling, right? When n is odd, n plus 1 is even, right? Even over 2 is still even. So these two exactly is n plus 1 over 2 is even. So exactly this formula, right? But when n is even, n plus 1 is odd, right? Odd over 2, yeah, it's bigger than n over 2 by 0.5. So that's why you take the floor is exactly n over 2. You take the ceiling is this guy. Okay? If you don't convince, you're not convinced, simple, put n in there, you know it. Okay? So why I put this here? Because if you try to do it Python or R, you start from scratch, this is how you write it. This is the median. Of course, this thing exists in your program. You don't have to actually model it. But if you know how to model this using Python R, because you may be developing much more elaborate program, before you do complicated thing, you know how to do the simple thing. That's why I have to talk about floor and ceiling. Okay. So the interpretation is in the middle, regardless of distance, right? Exactly middle guy. Okay. So let's have example. 1, 2, 3 is 2, right? 1, 2, 3, 4. The middle guy is 2 and 3. Average 2 and 3 is just 2.5. Okay. And 1, 2, 3, 40, which again, we have a 0 at the end, it's just still 2.5. So you can see we have a extreme value. Last guy doesn't change the median. Okay. So just to remind you is now we have a big data a lot of time or large quantity data. Usually the difference between mean and median will be very minimal. So we don't have to worry too much when you handle very big data. But still, if the data is very skewed, the mean and median can still be very different. So look at the income data in almost around the world. The mean is way much higher than the median. Reason? You have very rich guy making the mean very large. Okay, so that is the thing. So last one we want to talk about is the mode. Okay, mode is, you can look at the definition, it's very simple. Look at the maximum frequency there. Okay, so there's no addition, right? So that means that this thing can apply to categorical data, no problem, there's no addition. Okay, same as median, because there's no addition. So you apply to categorical data, it's fine. So that's why at the beginning I mentioned, we look at the restaurant rating, look at the median can be more useful because adding things is not really meaningful when the liking scale. Okay, but of course you can still doing the, when the data is large, mean, as I mentioned, mean and median don't different too much, still is meaning, still can be doable. Okay, and for the mode, there's a little complication about the mode because different textbook with different meaning. Okay. And when some textbook would say if every value appear once, they don't have mode. Okay. But we probably try to use the following definition. If everything appear once, we still call everything is mode. Okay. If everything appear, say this 1, 1, 2, 2, 3, 4, we have 2 mode. Okay. If 2 appear most, you just have 1 mode. Okay. One of the reason why you want to do this is because later when you R or Excel, that will be easier to handle. Okay. And I think we try to follow what the output you see from the Excel or R. So that's why the thing we define in this way is I try to either follow one of the formula, make it easier. For the R, you don't have, I don't cover R in this class explicitly. But if you try to look at that, you will the function called the MFX, most frequent data, that will actually end up with the mode. And mode later we'll talk about Excel. We'll talk the mode will give you this thing. Okay. Is that okay? We just very briefly go over the 3 things: mean, median, and mode. Okay. There's nothing new there, but just want to remind you, for median, the formula, you need to be careful when you actually try to do it in Excel or R. For the mode, there's slightly different definition for our definition of the mode. Okay. And some textbook will say there's no mode in this one. But we just make it a little bit more consistent, right? Because if you do this, when you try to write the formula, they'll be more complicated. But don't worry, in the real world, this thing, if happen everything appear once, then actually mode is not very useful anyway, right? Or you would have grouped the data so that you're looking the model group. Okay. In up to now, we actually don't talk about data processing, right? But in the real data, when you have a huge data set, you will not actually handle individual data. Instead, the data will group, like the income data, right? You don't have each individual income exact number, but probably you will say calculated for every interval of 1,000 or 10,000. Okay. And that thing mode, well, you don't have this problem, right? You have every observation would be more once, right? So you don't have this issue there, right? Because when you have group data, the mode will be easy. Okay. Now we're going to cover the next 5 stuff. I don't know we have time to cover all, but at least we cover up until variance, I guess. Okay. There's some technical issue for interquartile range. Okay. But the variance, the central concept for this person. But don't worry, they're very, very simple. Nothing new there and nothing difficult here. Okay. So remember that this person is trying to measure how variation of the data, how dispersed the data. Is data concentrated around the mean or not? So mainly it's asking the mean, the range, or the median. Interquartile range is looking at the median mainly, but also mean is also useful. Okay. So let's look at the range. Range is super simple. It is basically talking about what? The biggest minus smallest. Okay. So the larger it is how variation of data is. Okay. It's very simple. It gives you some idea of how the data looks like, right? Of course, it's easy to find outlier, right? So the maximum minus minimum data. Okay. Look at this. Example, you have 5 number. The range is 4 in the first case, 49 in the second one. Okay. And again, because outlier, for the range, you would want to consider winterized or trim data, right? Otherwise, it's not very useful, the range, right? Sometimes you cut out the top 10% or bottom 10%, right? Or 2% or 5%, depends on your purpose. Okay. So, but that is the thing. You want to clean the data before you work it out. Okay. In this class, we actually don't talk about clean data or data handling, right? Because the data usually collect, if you do it first-hand data, would be very dirty in the sense that all crazy thing would happen, maybe typo or here and there, you have to clean up thing, because most of the time we use secondary source, right? For your assignment, for your thing, we give you a nice thing. But when you actually go to work out the data, can be very crazy. And we don't have time to go for that. But when for most analysis, actually, I would say more than 70% of the time you spend on cleaning the data to be useful. Okay. But we don't have time to cover those. Okay. Unfortunately, right? But that will be the thing that you will learn along the way. But cleaning data and all those things will be things that of course cover in subsequent class when you actually hand on those data, right? And when you work on the project, you want to do some survey, I mean, you notice that you spend a lot of time putting data in the right format, right? If say suppose you want to use the Google form to collect data for a survey, go to the library and do it. Some people do it, right? And you have to actually make the data useful, right? Or you try to collect the data by filling a survey, ask people to do it, then you convert it to the data, the usable data can take a lot of time, right? Or even if you try to ask data from other people, they may not put in the way that you would want to do it. You have to handle it, clean it, and actually they spend a lot of time. So that's why you need to learn R and Python to do those things, and you should consult data camp for that. Okay. Now you learn range. Okay, biggest minus smallest. Okay, and is there anything other than the range because it's affected by the outlier? Yes. Look at the biggest and smallest. Okay, but look at the 25% to 25%. Okay, what does that mean? To be more precise, we will introduce a concept called quartiles. Quart by English means four, a quarter. You bake tiles means a square thing, the tile in the bathroom, like the tiles. And you divide the data into 4 parts, right? So suppose it is a cake here, right? And this is the median, the middle, we call Q2. And the first part, median of first part, so Q1, for first quartile. And median of the second part is called Q3. Okay. And interquartile range is looking at the distance of this. Okay. The range is actually this guy. It's a range. And the green one, interquartile range. Okay. You look at Excel, they will tell you this is Q0, the smallest one, and the biggest is Q4. Okay. This is Excel. Later you see. Excel, the range is Q4 minus Q0. Okay. And IQR, interquartile range, which introduced soon, is Q3 minus Q1. Okay. The good thing about this interquartile range, which is Q3 minus Q1, is it doesn't affect by outlier, right? Because it doesn't really matter the data, the smallest and the biggest, and look at the middle. Again, calculate IQR would require less precise data at the extreme, right? Because when we collect data, usually the extreme data is very imprecise, right? You ask Bill Gates how much you make, probably he don't even know, right? So that's a problem. So that is but when you calculate quartile, you don't have to exactly know what the biggest and smallest. You know he's very big, then you're done, right? So the range IQR is Q3 minus Q1. Is that clear? Okay. Now, intuitively, Q3 and Q1 is very simple, right? Because Q3 is the median of the top part. Q1 is median of the lower part, right? But when you have the data, you face the data, it's not very clear how you define it, okay? If you have very large data set. Okay, you find the median first and find the median of the both part. No problem. When your data is small, how to define this Q3 and Q1 is not very easy. Okay, so this is the quarter is Q1, right? 3/4 quarter is Q3, right? But it's not entirely clear how you define those. Okay, and if you look at R, if you try to look at quantile, look at the menu, they have 9 different ways to do it. Excel at least have 2 different ways to do it. Okay. The reason is median is very simple, right? Because median is when it is odd number observation, you have the exactly middle guy. You have even average of 2. But when you have Q1 and Q3, it's not very clear what is the Q1 and Q3. Okay, so let me talk 3 different methods. The first 2 methods will be the one we'll finish the quantile, then we will left the variance in the next class. Okay, the quantile, the first 2 methods is some of you learn in the high school, if they learn in high school. So this involves as what we have expect, you find the median twice. Okay, so what we're going to do is the first method is use median to cut in half. Okay, you still keep the median there within the data, and you do median again. Let me show you the example first. Okay, so the data is 1, 2, 3, 4, 5. Okay, the median is 3, right? The median is 3. Okay, method 1 will tell you that you include number 3 in your first half. Okay, then the median of 1, 2, 3 is 2. Okay, that's why Q1 is 2. And then look at the second half of the data, you still include 3, 3, 4, 5, and then you would take 4, right? So the IQR will be 4 minus 2. Okay, the first method, remember, you find the median first. Your median is the part of data. You keep it in your first half, the second half. That's it. Okay, let me give you another example. The same. If 1, 2, 3, 4, 5, 6, the median is 3.5, but 3.5 is not there, so it doesn't really matter. You just look 1, 2, 3, and 3, 4, 5, 4, 5, 6. The median is 2. The median here is 5. IQR is just 3. Okay, very simple, right? Operational. And the second method is a variation of the first one. You take the median, but you kick the median out of your game. Okay, so that is what we do. Look at this. 3 is the median, right? The whole data. You kick out from your data. Okay, so that's why look at first half is 1 and 2. The median is 1.5, right? Look at the second half, 4 and 5. The median is 4.5. The IQR is a difference between the 2. Okay, and when you have 1 to 6, the median is 3.5, right? It's not anywhere in the data. So this will give the same answer as method 1. Okay, so method 1 and 2 will coincide when you have even number observation. They will differ when you use method 1. Okay, but we will not use these 2 methods. Okay, because these 2 methods is rather inconsistent. Okay, we'll use the method what we call the linear interpolation. Okay, what we are doing is try to look at what we call the quantile function, which try to being consistent. Okay, this function looks very crazy. Okay, I think it's easier to show the example and then justify what it means. Okay, at least you know what's going on. Okay, so look at this. we have a data, we have 5 observations. So n is being 5, right? N plus 1 is 6. Okay. And we want to know 1/4 is a Q1, right? 1/4 of n plus 1. So 1/4 of 6 is what? Is 1.5. Right, 1.5. So basically is 1.5 is from 1 and halfway of 1 and 2. Right? 1.5 is, look at the first observation, and halfway between 1 and 2 is 1.5. So that's called the interpolation. Okay. Let me repeat the statement. Okay. Before we go. Okay. Because total number of observations is 5 plus 1 is 6. Q1 is 6, quarter of 6 is 1.5. Where's the 1.5 data? 1.5 data is the data number 1 and halfway between 1 and 2. Okay. And last one, I finish this statement. Q3 is 3/4 of 6, right? Which is 4.5. Okay. 4.5 will be data number 4, fourth data, halfway between 4 and 5. Okay. So that is how you get it. Halfway between 4 and 5 is 5 minus 4. And Q1 and Q3 is like this. Don't worry about this. I'll talk about again next class, which is next week. So don't worry. Okay. But if the idea is we are doing interpolation, looking at some similar triangle idea here. Okay. So don't worry. We'll talk about this next class. And just to remind you why we want to do this, because this is what you do in Excel. I try to explain why Excel gives you this answer. Okay. Anyway, I will see you next week. So remember, no class this Thursday. Okay, we'll do it next week.